graph x minus 1 over x minus 3. So to do that, I mean, we could do it on the calculator. You pull up your calculator, you could see what this looks like. And we want to evaluate the limit. What happens as x goes to 3? So first off, if we just plug into 3, what's going to happen? It'll be undefined. I'll be dividing by 0. But we want to see what's happening, right? So am I getting closer to a number? Do I just have a hole there? Or is it going to be an asymptote? How do we know?
Because it not goes to 3, so like it can never clutch, but it gets super close to it.
Exactly. So we're going to get really, really close to 3. It's going to be a vertical asymptote. The reason it's not a removable discontinuity, we don't have a x minus 3 factor on top and an x minus 3 factor on bottom. So when you have a factor on top and bottom of a rational equation and it cancels out, that's where your holes are going to be. But otherwise, you'll have an asymptote. After you take out the holes, removable discontinuities, whatever's on bottom, the x value that makes it divide by 0, that's where your vertical asymptote will be. So we see we're going to have vertical asymptote at 3. So I just want my calculator. Okay. So if I go to the home button, what the heck? All right, home button, and let's graph. Why is it so slow? Oh, was it this class? It was like glitching? Great. So happy to. Wonderful. Great. Okay, x minus 1. X minus 1. So tomorrow you will need the hats on because you'll have a question on the limits. I just want to make sure we finish everything today before we do it. X minus 1 over x minus 3. Oops, I need to have a parenthesis, x minus 3. Okay, cool. So if I graph it, oh my gosh, check out what happens at x equals 3. Literally, on the right side, as we get closer, the right-hand limit, as we get closer, it's going to positive infinity. On the left hand, as we approach from the left hand, as I get closer and closer to 3, it's going to negative infinity. So I'm not approaching a single number. Okay. So if I could copy, I thought I could just copy the window. It's fine. I don't know what it looks like. Oh my gosh. There's so much stuff open. Okay. So it looks something like this. Yeah. What do you think I was listening to when I was making my intermediate test or when I was grading your guys' test?
Lizzo.
Whenever I'm having a bad day, that's when I bring out the Lizzo because, it really boosts the self-confidence. All right, so consider the graph, literally graph on calc. It's not like I'm 70, we probably listen to some of the same music. So we're going to graph on the calculator. So we see there's a vertical asymptote at x equals 3. This is one point that some people kind of missed. So I see a vertical asymptote, but is there horizontal? How do we know? Horizontal. Leading term test. The leading term test. Okay. So leading term test says you take. Do I need to move you? I don't know. I just heard weird noise.
That was me laughing back. Cool.
Okay, I'm sorry I offended you. Okay, if you have a question, raise your hand. Other people probably have the same question.
Oh, I was just curious. I just want to know what the graphing question was like on the quiz because I didn't remember it.
Okay, cool. That was the piecewise.
Oh yeah.
Okay.
They were asymptotes on there?
So the leading term test says we're looking at the term with the highest exponent on top, and I'm comparing it to the term with the highest exponent on bottom. Guess what? These both have a value, an exponent of 1. So if you have a higher exponent on bottom than top, it's 0. If you have a higher exponent on top than bottom, there's no horizontal. You'll have a oblique asymptote. Remember this? And then if you have the same exponent on top and bottom, they're literally going to cancel out, and it's the coefficient, the ratio of the coefficients. AKA, what's the number in front of x? 1. 1 over 1. Guess what? Our horizontal asymptote is at y equals 1. So I come over here, horizontal asymptote. So wait, you're telling me if I go back to the calculator, the graph, I'm going to see there's a horizontal. Oh, if it opens, come on. Oh my gosh, look at this. It's like if I drew a line across that 1, I'm approaching, getting closer, but never touching it. There's a horizontal asymptote at y equals 1. So when you're doing domain and range on your test, some people forgot about horizontal asymptotes. So the range for a problem like this, we have to X out the fact y cannot equal 1, so it would be negative infinity, comma 1, parenthesis, union 1 to infinity. Okay. Okay, cool. Let's go back and forth, come on. This is so slow, this is so slow. Okay, so I have a vertical asymptote, horizontal asymptote, roughly what it's gonna look like. If I put in a positive number, like what about if I put 5? What number would it be? 5 minus 1, 4 over 5 minus 3, 2. Okay, something positive. This is how I graph rational functions. Remember, we decided I have 2 asymptotes. Am I going to be above or below? Well, I picked a number 5 because it's on the right side of my vertical asymptote. Plug it in. Okay, so positive on top, right? 5 minus 1, okay. Positive on bottom, 5 minus 3. It's going to be positive, so I know it's going to be up here. Maybe I'll do this a different color so you can see it. Because we... Okay, and what about if I put in like 0? What do I get?
0.
Negative 1 over negative. Oh, positive.
What's
Negative over
so at 0 it's positive 1/3. Well, okay, so it tells me it's on this side of my asymptotes. Something like this. Okay, cool. So we have the rough sketch of the graph, right? I could have just copy paste from the TI, but it's fine. We have a rough sketch of the graph, the exact vertical asymptote, the exact horizontal. We know which side it's going to be on. I could find exact numbers, but whatever. What we're really trying to find here is this limit. So let's work on finding this limit. Okay, remember, for a limit to exist, we have to have a left-hand side, we have to have a right-hand side, and they'd be approaching the same number. So let's do the left-hand side. So the limit of x minus 1 over x minus 3 as x approaches 3 from the left side, from the negative side. What am I approaching? From the left side, I'm going to, as I approach 3, right, I'm going through my x's. Notice what I'm approaching. What's my y approaching? Negative infinity. Wait, negative infinity is not a number I could put a push pin on, right? It's not a number I can be like, right here. I have a number line, it's right here. Like, no, that's not a number I can actually, like, see. Because the second I'm like, this is infinity. No, you have to keep going. So whenever we have a limit that's infinity, we say it does not exist. So we're approaching negative infinity, does not exist. Cool.
Can we just write does not exist?
I want you to say negative infinity, DNE. Right.
On the notes, it doesn't have the like negative on for you.
Yes. True.
So
So we're doing
we're doing both parts. I meant to see. If
yes.
actually-
Because in order to find the limit, I have to look at the left hand, right hand. If I'm approaching the same thing, I'll have my limit. We already see, you can see I'm not approaching the same number. We can see, okay, they're going to infinity and negative infinity, but just to make sure we understand the process, let's approach from the other side now. Oh my gosh, so as I come from the positive side, so I'm getting closer and closer to an x value of 3. Oh, what happens to my y? Goes to positive infinity. It goes on forever. It follows my asymptote, so it does not exist. So remember, our goal for this problem is to find what the limit was as x approaches 3. Well, we found the left side, we found the right-hand side, and now let's get to the actual limit itself. So the limit as x approaches 3 of x minus 1 over x minus 3, it just does not exist because I'm not approaching the same number. Okay. Now this is from like page 67 in your book or so. Problems 40, 42, 44. Let's go through these. I'm just gonna like call on people. Let's try to like get through this. But if you have a question, make sure you raise your hand because I bet you will not be the only person who doesn't understand. Let's start with Noah 40a. What is the limit as t approaches negative 4 from the negative side? So right here, approaching from the negative side, what value am I going to? 5. Perfecto. Ariel, what about the next one? 2. Okay, Maya Hermides, what about the next one? What's the actual limit then?
Does not exist.
Beautiful, does not exist because I'm not approaching the same thing. These don't match. You can have, see, this is the weird thing. My left hand limit, it's true. I have a number, it's right here. I know what it is. My right hand side limit, I have a number, right? Both of them exist, but the limit does not approach the same number. So the limit at the number doesn't exist, but I can have a one-side limit exist. Weird. Hannah, Fahuna, what about g of -4? What is the value of the function at -4?
Oh, easily it's 2.
Exactly. You're looking for that filled circle. What is the value of the function? So notice I could have an actual y value here and no limit. If I go on to the next one, let's see what's going on here. Shani, what is 42a?
42a? 0.
Well, let's see. As s approaches -2 from the negative side.
It's 3.
3. You have to make sure you're looking at the right number. Okay. Gabe, what about the next one? What am I approaching?
3.
I'm also approaching 3. Good. Samuel, what about this next one? What is the limit?
3.
Exactly. Since they match, since my left hand is equal to my right, that's going to be the real limit.
Wait, what about the other piece?
What other piece? This part right here?
Yeah.
It doesn't matter. That's not where I'm looking.
Because it doesn't approach 3.
No, I said
It
So it
doesn't
just
approach
doesn't matter?
-2.
Huh?
It just doesn't matter?
That's not the place we're interested in. We're interested in x equals -2. Sorry, s equals -2.
Okay.
Yeah. I could come back and be like, oh, let's find the limit of 0. Well, I have a left-hand limit. My right-hand limit doesn't exist. But that's not where I'm interested in. Elliot, what's the actual function value of -2?
The actual function value of -2 is none. Oh, it's 3 because
3.
they're the same.
Check it out right here. Nope, it's not because they're the same. It's because the function,
They both
it
go-
actually touches 3.
Well, that too. Oh, well, because it's actually.
Yeah, it's the function value. That's the function value. It's the function value.
If you
Okay.
look really closely, it's like it doesn't.
What? No, what? Look. Do you see right here? Right here? Check it out. Check it out. You can see it. You can see it.
Oh, I know what you mean.
You see? You see how it's touching right here? Do you see the blue is exactly on? Okay, cool. Cool.
No, I really don't. But on the paper, if you look really closely,
It's hard to see.
I wish I
Yeah.
had a little circle.
All right. Shh. Hannah wrote in. Shh. Focus. Ready? Focus. Okay, Hannah wrote in.
1.
All right, so I'm going to 2 from the left side. So I'm approaching 1. I don't like this color. I need to have a color that's contrasting. Oh my gosh. Purple. Okay, so I'm approaching 1. What about Spencer as I approach from the right side?
1.
I'm also approaching 1. Excellent. Maya Swartz, what is the actual limit here then? Yup, I don't know why that happened. All right. All right, so they match, so that's the actual limit. Awesome.
Give us the answer on the last one.
It's so little.
What?
Yeah, you
Yeah,
guys.
It's a little 3. There's a 3 there. It's so cute.
Oops. I was gonna have Tolly. Okay. What's the function value? 3. Great job. She doesn't have to say anything, and she got it right. Yo, top student. Okay.
No, she's not.
Oh,
So
so roasted. He's
All right.
getting a little jealous.
2.1, done. How about we let's bust through that extra practice. Let's go through. More practice, higher test scores. More practice, higher quiz scores. Okay. You do. There's 2 different things. Shh. All right, so there's 2 different things we passed out. One of them has a staple, the other does not. One says 2.1 extra practice. The other says 2.1 to 2.2 review. Does everyone have one of each? We should have 2 papers. 2 papers. We have 2?
Yeah.
We have 2? We have 2? 2 papers? 2 papers? I printed 14 copies. With Tal, there's 14 people in the class. Someone doesn't have it.
I have it. Spanish has
I don't think Noah has it.
Mr. O'Brien.
Yeah.
Printed 14 copies. Tal's gone. I have Tal's copies right here.
No, I have it.
You have
I
it?
do have it.
Someone doesn't have it. Guys,
Okay, do you raise up the paper? No, I'm kidding. Are you sure you didn't print?
I just put it in my binder.
This is for participation.
Wow, is it
Oh,
you?
wait.
Who's
Is
that?
No.
Noah is sitting in, I don't know her name, but Noah is sitting in somebody else's seat. Well, who's the one that's in there?
But that doesn't make a difference.
Never mind.
What is wrong with you?
Okay, cool. You know what?
I had no idea.
Let's do this. Hold on. Is everyone blank?
Yes.
Mine has the answers.
Oh.
It should not have the answers.
Just don't listen to Elliot.
Don't trust a word he says in general.
Look what Ty has. Ty has yours.
I have mine.
I think. Maybe that's why.
Slap him in the face! Wow, shit, yo. Way to shine him out.
We solved the problem. Bless Shani. I was like, well, the answers are gone. All right.
Oh, yeah, why did I realize the answer? Oh, damn it.
It's just like filled out.
Oh, damn it. Where does that come from? What?
Okay, cool. Let's breeze through this.
You're hindering my ability to learn.
All right.
Are we doing the review or the actual? Oh, never mind.
Ready? You know what time it is? Extra practice time.
Contract time.
Extra practice time. So we're gonna keep going down the list, and notice this is
Can I have my fourth function?
no calculator.
I don't need no calculator.
That's so funny, Noah. Wow, I've never heard that one before.
You sound okay. You know who you're like.
Oh my
You know
gosh.
who you're like.
Who?
You're like Miss Schmidt. I kind of like her.
So true.
Except Miss Schmidt has more stuff.
After this year.
And she gets more.
And also, Miss Schmidt didn't.
Wow.
Wait.
So
Were you,
But that's
no,
what
you
you're
didn't. Miss Schmidt won musical chairs last year.
Yeah, it was us too. It's because my finger got smashed from Mr. Masterman.
Oh yeah, excuses.
Did you see the bruise? Okay.
You didn't even try to pull the seat out from under her.
No, I was like dizzy because we were going around for 5 hours. All right, let's go through this. Tolly, what is this limit going to be? So first, how do you go about solving this? Ready? We're focused. Laser focus. Here we go.
I'm on number
17 minutes. That's all. Let's go.
Plug it in.
So we just plug it in. Guess what? This is a polynomial. We just plug it in. Awesome. So I have 3 squared plus 3 times 3 minus 8.
10.
3 squared times 3 minus 8. So that's 18 minus 8. That's 10. Awesome. Perfecto. Here we go. So I'm going to upload these solutions as soon as we're done. Awesome. How about the next one, Ty? How do I go about this one, Ty?
You plug in the -6 on the denominator and you see that it's 0.
So I have -6. Oh, let me pick it. This is not working well. So I have -6. No, this is fine. Okay. So if I plug in -6, why is this not changing color? -6 squared minus 36 over -6 plus 6. We get 0 over 0. Since this is, I'll wait a second. Do we remember what this is called? 0 over 0 is?
Zero.
Has a specific name, very specific name.
Undefined.
Difference of squares.
You wouldn't go to the Queen of England and say, "Hey, miss,
Oi, oi.
that's not correct term for her." You have to say queen. Here, you have to call it indeterminate form. Indeterminate.
Oh, yeah. I remember making a write down the whole
Yas
thing.
indeterminate form. Yas.
Wait, but when
Why? Man, I'm just trying to make it relatable for you, and then we go off on a tangent.
relatable? Relatable is not magically. Wait, relatable.
Let me channel my inner Malikian, and I'm gonna make sure we get through this. So what this means is I'm gonna actually have a backbone, and I'm not gonna let you walk all over me by being loud and talking. No, stop talking. If you're gonna talk, get out. Cool. I want to get through this. Here we go. So how do I rewrite this? So what I'm going to do is see if anything cancels out. Limit as x approaches -6 of, well, x squared minus 36 is a difference of squares. So x minus 6 times x plus 6. Beautiful. Over x plus 6. Oh my gosh. Guess what? These x plus 6's cancel out. So that means there's a removable discontinuity at x equals -6.
Yeah.
So it literally is going to look like a line, just a little hole in it. But the hole is where we're interested in.
But that's fine.
So we know the function value will not exist there, but there will be a limit. Awesome.
Yeah.
Limit as x approaches -6 of x minus 6. This is just going to be -6 minus 6, which is -12.
Boom.
Beautiful. So if you kept your notes from last year, pull out those chapter 12 notes as you're studying. Next person. We're going to the top list again. Noah. How about this one?
Well, we'll see. For this for this one, you can plug in 0, and 0 plus 3 is 3. 3 squared is 9. 9 minus 9 is 0 over x, and I don't know what's in. Oh, and then you plug in.
It's indeterminate?
So it's 0. And then so what you do is you break it up. So 3x times 3x minus 9 is over x, and then I don't know.
What is this?
Do a difference of squares.
Exactly. It's going to be a difference of squares.
Because it's squared into x.
Exactly.
So it's going to be
That's a square. That's a group of squares. That's like
3
one
plus
number
x
squared.
squared. Difference of squares is
3
3
plus
plus
x
x
is minus
times
3.
3.
So-
No, a difference of squares
Okay.
is the whole thing.
What she
3 plus
means-
x squared
You
is
know,
a square,
something
and 9 is a
squared
square.
minus 9.
So that's a square, and 9 is a square.
So it's 3 plus
But
x
then-
minus 3 and 3 plus
It's not
x
gonna
minus
cancel.
It doesn't really help you.
Right. Okay. So
Just
true.
foil.
We recognize difference of squares, and it's not really gonna help us, but Samuel says foil. So what if we foil this together?
I am Samuel.
You like that?
Then you get 9 plus.
I'm an adult now.
This is right now 117
Samuel.
my nickname that I put on that.
No one knows it. No one knows it.
Okay.
X squared over x and x's cancel out, so it's 6 plus x. And then
9
0
plus
is
6x
so it's 6. The
plus
answer is
x
6.
squared. Oh wow, that's a
Answer
lot.
is
Shh. Kindness, circle of kindness. I heard someone call him shut up.
AP kindness.
Yes.
That's a combination of two.
So
It was history shop today.
true.
Oh.
What?
What? Is that just I don't?
No, that wasn't Saturday. I was just saying, like, oh, okay, you knew.
Yeah, I remember last class we also talked about this.
I wasn't there.
Oh, oh yeah, because you were sick.
Yeah, but I'm better now.
Okay, cool. Did you see I uploaded everything to my Jag?
Yeah.
You didn't. Whatever. Just to be clear, the expectation when you guys are gone is you watch the screencast, you fill out the notes, and then if you have questions, come to bonus, whatever. Like I want you to catch up before you come to me. I'm not just gonna reteach the lesson for you. If I'm doing this, I want you to have specific questions. Okay, so I have 6x plus x squared all over x. Guess what? The x's will cancel out, and I think someone was saying this. 6x over x is 6 plus, well, x squared over x is x. So if I plug in 0, I now get 6.
Boom.
Awesome. So what this means is, I do have a limit there, so it must have been a removable discontinuity
At 0.
at 0. Okay, next, Ariel, what do I do here?
Factor out the. Oh no, you can just.
What's the first thing we always try? We always try to fill it in.
Fill it in, but
So that's why I was showing you the indeterminate forms, because we always try. The easiest thing, fill it in. Once I fill it in, I get something crazy. Then we gotta try something else.
you can fill it in.
Yeah, we can. Exactly. You just try filling it in.
Okay, the root.
Square root of 16 minus 8 plus 1.
Good old 9.
Why is my pen is just like dying? Do you see this? I just this turns into square root 9, which is just 3. Cool. Next, Hannah Fahuna, what about this one?
Oh, you take out an x from the top, and then you.
What does this turn into?
1, 9.
0
1,
to 0.
9.
It turns into indeterminate form, because 1 squared minus 1 turns into 0 on top. 2 plus 5 minus 7 is 0 on bottom. So, Hannah, what did you say we should do?
Maybe take out a 0 in the first one.
Oh.
Does that make sense?
Take out a x.
X, comma,
X times
1.
x minus 1
Yeah, thank you.
over.
Over. You factor it.
Okay.
So 2x. Ooh, this is putting out about 3.
Well, what multiplies to -7?
7 and 1.
Yeah, so we know the two things have to be a 7 and 1. The question is which goes where. So if I try to put a 7 over here, I'll have a 14 or something.
The 7 goes in the first one. And then, yeah.
Okay, how about let's take a pause real quick, and I'm going to remind you how to do factoring with
Oh, I don't know.
coefficients other than 1. So since I have 2x squared plus 5x minus 7, what I can do is multiply by 2 here. So I have x squared plus 5x minus 14. So now if I factor this out, what would we get?
You get, can I say?
Yes.
You get 2x plus 7 in one parenthesis, and then the other x minus 1.
So 2x minus, sorry. Wait, did you say what?
1x minus 1.
1x minus 1.
No, 2's in the first one and 1's in the second one.
I think
2x
two's in
plus
the first,
7
yeah, 2's in
and
the
Yeah,
first one.
beautiful, beautiful.
2 is in the first.
Yeah. Yeah, well,
You just said
I was trying to go through the case-of method of showing you how to do coefficients other than 1.
Is that way you don't have to have a 2x in there? Is that...
You have to have a 2x in there. So the idea is you go through,
So, wait, how is this different from what I did?
hold on. So if I have, so x minus 2, right? That would be what the factoring is? For this one right here, is that what the factoring is? Yes, yes. For this one right here, that's what it is. Yes, 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 yes. Okay, cool. So the case-of factoring method says, guess what? If I go through and I put in my 2x, is there one of them that I can simplify? Yeah, the right side. So if I divide this whole thing by 2, I will get 2x plus 7, and then I have x minus 1. That's, yeah, so notice that the 2 cancels out here. This is one method. If you have more questions over this, I can give you the little handout about it. I mean, you also can come to bonus. Like, people don't come to bonus. Okay, so if I cancel this guy out, guess what? I'm left with limit
Whoa.
as x approaches 1. I don't know why my pen is so bad. That's better. Well, it just was weird because like it's the fat one that like tries to the fat pen that tries to do stuff. You know, like how it was whatever. Like right here, you see that little nonsense little bead right there?
No, I got it. What right there?
Bead, whatever. Okay, limit of x over 2x plus 7 as x approaches 1. Shh. Are you guys done with this problem? We can go faster.
I'm done.
Okay, so this turns into 1/9.
It's 1/9.
Okay,
What did you do?
all right.
Oh, you just right. What?
Yep. Next one. Who would I leave off on? Shani, what's the next one?
√3.
Yep, because I'm taking limit of a constant. Literally, this is y equals √3. It's just a constant horizontal line. So this is what this would look like right here. So what's the value of -2? Oh, √3. What's the value of 0? √3. What's the value of 5? √3. It's a constant function.
Wait, I got a quick.
What?
It's about the
5.
5.
Yes.
When, like, the last step where you just got rid of the, oh, yeah, never mind. No, I got it. That's...
Plugged in 1. Okay. Next I have Gabe. What about, how do I do this one, number 7?
Okay, so I had a question. When you have the x on the bottom, that means you multiply the top numerators by x, or you multiply the denominators by x.
Well, first I want to get rid of the
Okay.
fractions that are on the
Yeah, yeah.
numerator,
Yeah, okay,
and
so-
then
so
I can deal with the whole
multiply-
thing.
multiply both
So
sides.
first, before we do that, we see this turns into indeterminate. Okay, so we gotta do some work. Easiest thing is just plugging it in, but this is not gonna work. So if I multiply this by 3/3, I have to have a common denominator.
Yeah.
multiply this by x plus 3 over x plus 3. Okay, so this is limit as x approaches 0 of 3 minus x plus 3 all over 3 times x plus 3. Then this is all over x. Oh my gosh. But if only we could simplify this a little more. Oh wait, just kidding, we can.
We can.
We can.
Multiply the bottom by
What the heck?
Wait. I'm sorry, do we have a question? I don't see a hand.
Yeah.
Okay, Elliot and then Gabe.
Can we just now multiply that bottom by x?
Multiply the bottom by x. Like this one right here?
The middle denominator.
This right here?
Yeah.
No, you can't multiply by x.
No.
Okay, but
Instead of dividing by x, oh, okay, I see what you mean. Well, yes. Yeah, I mean, you can, but I want to I want to show like a couple more steps.
wait, if you
Just to make sure. Okay, so guess what? 3 minus x minus 3, that goes away. So I have x over 3 times x plus 3. Remember, we have to write limit as x approaches 0. What? It is negative x.
We have to write that.
And then instead of saying divide by 0, I can multiply by 1 over x. The limit? Yes. You have to write limit every time. Every step. He asked that last time.
Last year.
Well, unlucky for you, I'm your calculus teacher, and I'm telling you have to write every time.
I wasn't arguing this yet.
Ah,
Lucky for you, I don't have.
lucky for me. Lucky for me. Okay. Instead of dividing by x, I multiply by 1 over x. The x will cancel out. And I'm left. Oh, interesting. Interesting. Okay.
I was right.
So left with limit
She got asked that in the next one. I have no idea.
negative 1 over 3 times x plus 3. So this turns into negative 1/9. When I plug in 0 here, negative 1 times 3 times 3 is negative 1/9. Awesome. I think we can get through the next one.
0.
So what we're trying to do is figure out.
I'm gonna be honest. Straight up don't know how to do this.
Okay. So what if I rewrote this a little differently? And you're gonna be like, that's not different. False. It is. What's the first thing we went over in our notes about limits? What's the first limit we took? Sine of x over x. What's the limit of sine x over x?
X.
What? I'm sorry. Go to page 2. Page 2. Example. It's 1. Okay.
That makes sense.
So if you remember the properties of limits, if I take a constant 2/7 and multiply by limit of a function, wait, what I can do is just multiply 2/7 times the limit of x approaches 0 of sine of x over x. Because we know this from the first example in our notes, page 2, mid-page. We found the limit of sine x over x as x approaches 0 is 1. 2/7 times 1 is 2/7. Okay.
Oh. That
This
was
one's 0. Is this one 0?
Yes.
Sine of x over x is 1.
Yes, the limit.
Because is it because of the leading term test?
It's because we looked on a graph and we found what it approaches.
No, the one you're writing.
It is going to be 0.
Wait, hold up. What's that last
Because the leading term
one?
Yeah, because it becomes negative 2x over 5 and you plug in the 0, and you can't get 0 divided by anything.
Wait, what are you doing for that last
Wait,
one?
wait, wait,
No, I know that.
So if I plug in 0 here, I get 0.
0, wait, hold on.
Okay. So,
Do the last one.
number 9. Alright, this is where we're going to end because the rest you can do. We know how to do graphs. So here, I pulled out x squared. Because x squared times negative 2x is negative 2x cubed. 5 times x squared is 5x squared. So x squared cancels out, and I'm left with negative 2x over 5. And if I plug in 0 here, before I've been indeterminate, but now I get 0. So the rest of the page, we spent the first part of the class on.
We turned it for grade homework.
We turned it in for the quiz.
Yeah.
This is not grade homework.
See, that's what I thought the triple worksheet was.
But it literally saw you were.
Wait, Miss O'Brien,
There's a lot of stuff on the homework page that's not actual homework.
False. If you look at the lesson
No, for a
plan,
lot of my other classes.
the lesson plan tells you what's due.
For the test.